Hello everyone. In this video, let's discuss about deadlocks. What are deadlocks usually in a multi-threaded environment, and how they occur, and what to do to resolve those deadlocks. We'll discuss later. But earlier we have discussed about locks for locks and semaphores, where in multi-threaded environment. When two threads tries to access a resource at once, so using locks and semaphores we can mitigate those issues, like we can lock the resource or critical section of a code, or using the semaphores, using the wait and signal and all. So but we also discussed that locks and semaphores, we need to use it effectively and efficiently, otherwise it will also result in deadlocks. We'll discuss that also today. So basically deadlock is a situation where we'll better describe that using a diagram. For example, let's say in this diagram, where this car is waiting for this car to move and this car is waiting for this car to move, so this is a condition of deadlock, okay, where nothing can go anywhere. These two are pretty much blocked, waiting for each other. So likewise in a multi-threaded environment, if two threads are waiting for each other to complete, or if two threads are waiting for a resource, so one is waiting for a each thread is waiting for a resource to get acquired, then also a deadlock condition can occur, where both the threads will be locked indefinitely, and because of maybe a circular dependencies also, where one thread is depending on second one to complete, second is depending on third one to complete, and third is depending on first one to complete. So basically to discuss theoretically, it's a situation in concurrent programming where two or more threads are blocked indefinitely, waiting for each other to complete. Correct? This can be possible if you don't do multi-threaded coding properly or efficiently. Deadlock can also occur when tasks or threads hold resources and wait for other tasks or threads to release resources. If one thread is holding the resource and it is not releasing, and if other thread is waiting for that resource, then it's like results in a circular dependency, and a deadlock can occur. So of course deadlocks can significantly impact the performance and stability of an application. Of course, if it is a situation where two processes will be blocked indefinitely, then there will be a glitch and it can lead to anything in the application. So let's see the situation, so that if we can look at the situation, we'll understand, okay, this type of programming can create a deadlock, and also for which I have created some examples where first in place, a deadlock mainly occurs because of writing a synchronous operation in another synchronous operation. So let's say usually we do this, which can lead to crash actually. So for example, this is the global main queue I have taken. Global main queue asynchronous operation we generally do to do a UI update when we call a service asynchronously. So once we get the service call, we generally do async operation. But what if we do the synchronous operation? So mainly the deadlock conditions, the cause of a deadlock condition usually occurs when we use the synchronous queues. So why? Because concurrent queues they happen asynchronously, and like that it goes, whereas in synchronous operation one has to be completed to go to the next one. So in this case, generally, for example, you have taken a main queue and a synchronous operation. So what happens now? This waits for this to complete it. Correct? So why? Because this is a synchronous operation. So if this needs to be completed, this needs to be completed. If this needs to be completed, this needs to be completed. Why? Because these are synchronous operations. So to be frank, if this is a main queue, this is the first task you have given to the main queue. Correct? That first task is this complete thing, and to the same queue you have given the second task. For example, let's say this is the task. So instead of this is the task. So task 1, this is what you have given task 2. The same queue, it is having two tasks. to do this needs to be completed. To complete this needs to be completed on this queue. Then only you can say like on this queue both the operations are executed synchronously. But whereas if you try to execute it, it will result in a crash. Okay, let me run it cleanly again. Crashed. So what it is saying, the process has been left at the point where it was interrupted, used to return the state before expressing evaluation. This results in a crash. Of course you can try that in your code, in your application. As this is playground, you can't see the crash, so but it is showing an exception. That means it's a crash actually. Okay, but whereas if you try that in your application will suddenly gets crashed. So why? Because as you understood, to the main queue synchronously you're trying to do two operations within each other, whereas one waits for other to complete, which results in a deadlock and nothing gets happened, whereas it results in a crash also. Okay, this is global mail queue. Let's say normal dispatch queues we take. Here also the same thing happens. For example, I have taken a dispatch queue instead of a global queue. This is my own queue. As I am not giving attributes, if I don't give attributes as concurrent, in concurrent situation it will not happen, then it is a serial queue. Now pretty much this I call it as this is a serial queue, correct? So serial queue, same, again same like this waits for this waits for this, nothing will get executed. And okay, let me take it to the top so that this will not get executed, or let me comment it so that as we already discussed it. Okay, let's see this, let me try this. Crash. Okay, whether it is a global main queue or it is this queue, so this is what happens, the crash will happen. Why? Because this, if this has to completed on this queue, this also should get completed. This, if this has to be completed, this has to be completed, so this will result in a clash. Of course we call it as a deadlock. Whereas for example, if it is not a serial queue, then that means both of it. So let me run it and see that. See, to a concurrent queue you have given two synchronous operations, so it will execute it properly. You can print me, you can't print me. Run it again, you can print me, you can't print me, correct? First this gets executed and then only this gets executed. Why? Because these are not a synchronous operation, so it will happen properly, whereas the crash will not happen, deadlock condition will not happen. Why? Because it's a concurrent queue. That means it can do parallel operations. It's not like there is no mandatory, it's not mandatory that this has to be completed for this to complete, something like that. So basically we need to be very careful if we are playing with the serial queues, especially in this, if we are doing something synchronously. Okay, it is a single queue. Now let's talk about two serial queues. For example, this is one queue, let me uncomment it for you. Okay, for example, there are two serial queues, Q1, Q2. So again the same thing, these two are serial queues, and of course you are doing the asynchronous operation. Whereas inside an asynchronous operation you're trying to call synchronous operation needs to be happened on Q2. Okay, in the same way you have second queue, you are doing a synchronous operation, which is good, whereas you are trying to do the synchronous operation on Q1. So this will result in deadlock. That means as you can see, task 2 is started, task 1 is started, after that nothing got executed, this is not executed, this is not executed. That means a deadlock. So your processes are locked basically. That means Q1 is trying to execute a block on Q2, Q1 is trying to execute a block on Q2 synchronously, and Q2 is trying to execute a block on Q1 synchronously. So let me show what is happening here, why these are getting blocked in a pictorial way. I have just written a diagram. So for example, Q1 and Q2, this is what we have taken, it's a serial queue, So Q1 first step is what? Task 1 is started. Okay, as it is asynchronous operation, these two are asynchronous operation. Q2 first step is also print Q21. Okay, task 2 is started will get first, task 1 is started will get, sometimes task 1 starts first. Okay, why? Because these are asynchronous operations. Now coming to the second step, here is where the deadlock happens. Now when I come to the second step here, for example, so Q2 synchronous second step of Q1 is synchronous block on Q2. Second step of Q2 is synchronous block on Q1. Now what happens? Q12 needs Q2, Q12 Q1, second step needs Q2, whereas second step of Q2 needs Q1. Hence there is a deadlock. When, as these are asynchronous operation, when they come here at line number 64, at line number 76, each one needs each other synchronously. Correct? So that's where there is a deadlock happens. Why? Because though it's an asynchronous operation, here you are trying to do async. So for Q to complete this, it has to complete this synchronous operation, whereas for Q1 to go for this, it has to complete this. So as you are doing a synchronous operation in an asynchronous operation, and you are doing it on another queue which is also waiting for the same queue, here what is happening? Each one is waiting for each other. That is where the deadlock is happening. So here synchronous block on Q2, synchronous block on Q1. Q12 needs Q2, this step needs Q2, whereas this step needs Q1. That means these are not asynchronous operations also. If these are asynchronous operations, no issues at all. Let's say for example task 1 is started, executed, then as it is asynchronous it will come here. Task 2 is printed, as it is asynchronous it comes here. Now on Q2 you want to have some asynchronous operation, so you want to, technically you want this to be blocked. That means I need Q2, whereas Q2 is expecting this one. So if you want Q2, you need to complete this, then only on Q2 you can do something synchronously. The same thing happens here. If you want Q1, you need to complete this, then only Q2 will be available for you. So that is the reason program stops here after printing this statement and this statement. So as there is a dependency, see, one queue is waiting on another queue as per this, hence there is a deadlock. As you can see, of course it is not getting crashed, it will not go further. So that's basically the deadlock happening scenarios, where if you are using serial queues, we should be very careful. If you are doing the synchronous operation, we should be very careful. If you are having multiple queues, you are using another queue in a queue, just to look at whether how you are calling, how you are fetching, there could be a deadlock condition. Okay, so one way to deadlock a program in Swift is to dispatch synchronously to the current queue, which we discussed. Dispatching synchronously to the current thread. If in the current thread you try to dispatch it synchronously, even if it is having, see, in the current thread you are trying to dispatch synchronously something, even on the same queue, other queue, boss, there will be a deadlock. So putting these types of codes, especially in a code, will immediately result in a crash before our print statements getting executed. So that is the reason we should be very careful with using synchronous tasks and serial queues. So pretty much, as you can see here, the first task of Q1 tries to synchronously execute a block on Q2, while the first task of Q2 tries to synchronously execute a block on Q1. Correct? So this is actually creating a circular dependency. So it's we need to ensure to avoid deadlocks, that we don't create these situations where tasks are mutually depending on each other. So generally, to avoid this kind of deadlock, we should use async basically to access the other queue. So for example, if you want to access other queue, it should be asynchronously you need to access it. So these things we should be very careful. So alternatively, we could use a dispatch group to synchronize the execution of the task across both queues. So that's where we need to properly take care of queues and synchronous operations in the multi-threaded environment. So this is what happens, and to avoid resource race conditions, like one thread is waiting for one resource and the second thread is waiting for other thread to continue. So we generally use, for the critical section of the code, we generally use NS locks and semaphores. So if we don't properly use locks and semaphores also, there will be deadlock situations that we will discuss it now. So for which also I have written some examples pretty much, where we can see, like, see for example, there is a circular dependency. That means, so for example, there are two locks. For example, let's say this is the first thread, and it is having two locks, and it locked both the locks, and it has done something and unlocked it asynchronously. For example, second thread, in the reverse order, it tried to lock, and it is an asynchronous operation, and you unlocked it in the reverse order. So what happens, as you can see here, it is basically the circular dependency that is happening. So it entered into thread 1 and it entered into thread 2. That's it, a deadlock. See, these statements are not getting executed. Why? Because thread 1 is waiting for lock 2, thread 2 is waiting for lock 1. Correct? Here you locked it, you are waiting for lock 2, whereas lock 2 you already locked it, thread 2 is waiting for lock 2. Correct? So we should be very careful when using the multiple locks. Here they can create a deadlock situation. So we should avoid using the nested locks or long running operations in locks. So these things we should be careful. Why? Because if you're using the logs, we need to see if other thread should not be waiting for that log. Next one, so that this is what we call it as circular dependency. If you can see in this example, two threads are created and each thread tries to acquire the other lock before releasing its own. So if you want to use another lock, actually you're doing something and then you release your lock, then actually you need to try to access other lock, so that if other thread is waiting for your lock, no, so then it will get the lock, and of course it can give you this lock. Correct? Instead of that, first you are locking both the things. That means you locked your lock, fine, other lock also you are using and expecting it to lock, then that can create a circular dependency. Correct? Before releasing its own lock, resulting in a circular dependency. This causes both the threads to be blocked, waiting for other thread to release the lock, they need to proceed. This situation can cause thread locks. So we should be very careful when using the locks also. For critical section of the code, we usually use the logs, so that critical section will be accessed by only one thread. We have discussed this already. The second situation is lock contention, which is a disagreement or dispute between locks. So let's see what it is. For example, I have only one lock, I have a thread, and for example here I already locked it, but my inner thread is again trying to get the lock. For example, this is waiting for lock, it already locked it, not released it, it is waiting for the lock, whereas it already locked it and it is waiting for lock. So in this situation, let me comment this piece of code. So in this situation, what happens is nothing gets executed, or one is get executed. That means either only one will have the lock at a time. Sometimes the one thread, sometimes the another thread. If you can see, sometimes this will get executed. Let's see. See? So here actually what happening, two threads are created and each thread acquires a lock on lock, However, each thread tries to acquire the same lock again before releasing it. Results in lock contention. That means a disagreement or dispute between the locks where, for example, this is asynchronous. I locked it already. For example, again you came to lock. Of course, you can't lock it. Correct? So that is the reason. Basically, only one is getting executed and other will be completely blocked, which is also like a deadlock condition, which can happen due to lock contention. So while we are using the locks, we should be very careful. Third one, which is resource exhaustion. That means of course we use semaphores. Semaphores basically work on a count where we wait for a resource, and once we are done with the resource, we generally signal it. Correct? For example, let's say I have two semaphores in this example. So two threads. So in this example, two threads are created. This is thread 1 and this is thread 2, and each thread waits for a signal from the other thread using semaphores. For example, let's run this code, then we can see. For example, let me comment the other piece of code so that we can focus only on the resource exhaustion example. So here what happens if I run this? So only the first one and second one are waiting. Here it is same like lock. So first one is waiting, second one is waiting, and you are expecting see, as you can see here, you are waiting. Semaphore 1 is waiting, semaphore 2 is waiting, and signaling is not there. 1 is waiting for a signal, so this will never get executed. Okay, so 2 is waiting for the signal, as this will never get executed, this will never get executed. Correct? So we should be very careful when using two semaphores or two locks. So first you need to properly unlock and then go for the other lock, and you need to properly signal it, and then you can go for the other semaphore. If the signal is not sent by the other thread, so you are asking it to wait, you are not sending the signal. That means this completely will become, and you are not sending the signal. Actually, when you are saying to wait, for example, when you are done, you are supposed to send the signal. Correct? You're supposed to send the signal. When you send the signal, I think for example, this is done. For example, here also, or to understand it betterly, so you are asking it to wait, then at least you need to signal it. Properly means, where we can put properly means, for example, this is waiting and this is waiting and there is no signaling. At least here, if we can so to fix this deadlock scenario, for example, this is waiting, so I release the signal. Let's say 1 dot signal. Okay, after that, as it is waiting, now I signal it. So wait, and after that signal. So somehow here, to fix it, as it is a generic example, it's not happening, but basically if we are using two semaphores, we should be very careful in giving the signals properly. If the signal is not sent by other thread, the thread will be blocked indefinitely. That means if I am waiting, I think I need to first signal it. Okay, if here I am waiting, of course I signal it. Semaphore here, it's not required and this is not required. If I run it, I would love to see everyone. 2-1 got executed, 1-1 got executed, 1-2 got executed, 1-3 got executed, 2-2 got executed. So if the other thread is not releasing the signal, if the signal is not sent by the other thread, the thread will be blocked indefinitely. So here I am waiting, you signal it here. Here I am waiting, you signal it here. So based on that it happens. So that's how somehow by doing proper locking and unlocking in case of locks, and doing proper waiting and signaling in case of semaphores, we need to make sure that the deadlock condition will not happen in concurrent programming. This can happen due to resource exhaustion. So resource will get exhausted, that means it will get exhausted obviously if the signaling is not happened. The critical section of the code is with one thread, so it will get exhausted. And it can happen due to contention, disagreement, where you are using the lock on the lock again, so only one thread will get executed. Or if you are trying to lock both the locks that you are having, which you create a circular dependency. So that's basically the deadlock conditions. So actually, to avoid deadlocks when using threads in iOS, it's important to be careful when we are using the shared resources, and to ensure that resources are released in a timely manner. It's also important to avoid nesting synchronous tasks with asynchronous tasks. This can also increase the likelihood of deadlocks. So we need to avoid nested logs, avoid long running operations in logs, and using timeout mechanism to release logs after a certain period of time. In the case of semaphores, we discussed semaphores is having, we can have wait and wait timeout, so that if it is not happening, so wait timeout, if it is not happening, it will not wait for it. So for example, let's say, of course we fixed it. For example, let's say the same stuff here. So instead of wait, I think let's do with some wait timeout. Let's see if we are able to fix the deadlock and all. Now plus some 2, let's say. Okay, so that this is still there. Okay, let me comment it. So if you can see, everything got executed. Of course, let me run it again for you. So see, just the wait out, just the wait time I have given only for that one. Maybe let me see. I'm also just trying if we can fix it or not. For example, dismiss timeout after 4 seconds or something like that. So my idea is to just fixing the deadlock somewhere. So these are the situations that we need to keep in mind before using logs, semaphores, or any synchronizations. No, it's not happening. Maybe it happened. It's happening. So after a timeout, I think we are able to fix the deadlock if we use the timeout. So something like this we need to use to fix the deadlocks. Otherwise our application will behave very weird, and there are chances of getting crashes also in this case of where if the process are not executing, which is fine somehow, whereas if the app is crashing, it doesn't look any good in the production. Correct? So we should be very careful. This is a common issue that can occur when using threads in iOS development. Occurs when 2 or more threads are waiting for each other to release the resource. A common problem in multiprocessing when several processes share a specific type of mutually exclusive resource, soft lock or software, something like that. So these are pretty much the scenarios of deadlock. So in a pictorial format, we should not create this type of condition, one waiting for another. One should not wait for another. So at least if there is something like that, we need to have a timeout. A process 1 waits for process 2, but for a particular time. Then somehow we need to avoid creating a circular dependency. Okay, so that's basically the deadlock conditions. Hope you found it useful. Thank you.